You accepted a new job at a company with a contract guaranteeing annual raises. You will get a raise of $5,000 every year and had a starting salary of $70,000. Write an equation for S in terms of N, representing your salary after working N years for the company. So we know we're looking for a slope-intercept form right here, y equals mx plus b, where m is the slope, and then the plus b part right there is the y-intercept. Now, in addition to that, they did tell us right here the x and y values. They said s in terms of n, and we know it's always y in terms of x. So instead of using a y here, we're going to use an s. And instead of using an x, we're going to use an n. Okay, so did it give us a slope? Yes, it did. It said the slope here, instead of it being a slope, of course, with word problems, we're expecting some kind of unit rate. And that's what it gave us. So the unit rate, $5,000 every, you could even show it as 1 year right there. But that would be our slope of 5,000. Okay, and that is the nice thing about this. It really is just filling in blanks for us, right? Like, do you know what y and x are? Yeah, it's s and n. Respectively, you change those letters and then you just fill in the blanks the rest of the way. Did they give us a y-intercept, which for us is some kind of starting value when we're looking at word problems like this? And yes, they did give us a starting value. It's your starting salary of $70,000. So instead of a B, now we have a 70,000, which is positive. Now that's good. Some students actually prefer to write this. It's exactly the same equation, but it's written in a different order. So they say your salary, you know you're going to start at $70,000. And then every year after that, you're going to add another $5,000. But again, that's for every year that you've worked. So either one of these is good. It really depends on your preference. But it is exactly the same equation. It's just shown two different ways. Here's our objective for the day. I can write equations from word problems. And also I can interpret and solve for x and y values and slope and y-intercept from word problems. You'll notice that this is exactly the same two objectives that we saw last time, but these problems, for the most part today, the problems are all going to, not all, most of the problems today are not going to give you the y-intercept, okay? So if they do not give us the y-intercept, then we know that we got to use the y-intercept formula. Which is the same as taking an x and y value from an ordered pair. So the y minus the slope, and that would be multiplied by the x. We've seen this formula several times already, but we're going to see it today now with these word problems. We saw an example last time, but now we're going to see a lot more on today's assignment and classwork. So take 30 seconds, copy down the two objectives, and then yes, there is a mastery quiz for this section next time, 2.7. So we do know that in order to write the equation of a line, you need two things, the slope and the y-intercept. We did see that example with the coins, where you do not need the slope and y-intercept. So for the most part, we're looking for the slope and y-intercept though. Okay, now back when we were looking at graphs and just kind of regular problems with ordered pairs, that was great. But now with the word problems, we're looking for the slope, which is also going to show us, it's going to be shown to us as a unit rate. Now, the unique thing about a unit rate is that usually it's going to be worded as something per something else, or it could be written a little differently as something for every something else. Now, they're not going to show you the one, but it's usually for every one of something. And so you have to keep that in mind when you're looking for the unit rate. It may not show you the one, but that's the unique thing about a unit rate is one of the values is a 1. Now, the other thing we're going to need is the y-intercept. But like I said, most of the problems on these assignments are not going to give us the y-intercept, which when we're looking at word problems, it's some kind of starting value. And because these problems were written by math nerds, sometimes instead of saying starting value, they may say initial value. Because if you just said starting, I mean, that's a pretty common language right there. But if you said initial value, then you look like a math nerd and people think you're smarter than you are. That's why we use it. But like I said, they're not going to give us the y-intercept. So we've got to look and find in the problems they're not going to give us the ordered pairs. We have to actually find them ourselves. Okay, and it's always the x value then the y value. They'll usually write it as some kind of y in terms of x though. Okay, so you have to look for that kind of wording in these problems, which then tells you which is x and which is y. Now, some of you guys don't need that because you know that the y is the dependent variable. And usually you can tell which is dependent just from the wording. Something is depending on something else, and then the x is what we call the independent variable. So this takes you back to some of your science classes. They stole it from math because they're jerks. And they want to look smart like math people, but it was a good effort. So once we get that information, right, we have that ordered pair, which we will find. We'll have to determine those values. Then we go to the Y-intercept formula, which we just saw. The Y-intercept formula, where you take the x and y value from the ordered pair and the slope, and then it plugs in this way, right? So it's y minus m times x. It's always minus, by the way, even if the m or x are negative. Doesn't matter. We're just using a calculator to make this calculation for the y-intercept formula. Once we have that information, like I said, they'll probably give us a slope, so we just plug that in to the equation. And then the y-intercept, once we find it, then we can plug it in there. Okay, so it's like you're just filling in blanks right here, where you just got to find your y-intercept or your slope right there. And then once your y-intercept, you find it. If it's positive or negative, then you just write plus or minus whatever the number is. Okay, so we're just filling in blanks. That's all we're doing. And then again, instead of using y's and x's, we may use different letters. So once again, though, the slope formula here at the top, we're not going to be using it today, but it will show up on the quiz. They're going to give you two ordered pairs, one of which is usually the y-intercept sometimes. And then you can put your y-intercept in as one of the values, one of the ordered pairs, and then the other ordered pair fits in here, then you find your slope. But again, you have to know you're finding the slope because it won't give you the actual rate, but it will tell you two values that correspond with each other and maybe even some kind of initial value. So you are moving and must rent a truck in addition to an initial fee. The rental company charges a fee of $2.50 per mile driven. If you were to drive 2 miles, the total cost would be $25. Write an equation for C in terms of M, representing the total cost of renting the truck if you were to drive M miles. So again, the first thing I would probably want to acknowledge here is it's C in terms of M, and it's always Y in terms of X. So I know what my Y value and what my X value are. And so when I get my ordered pair here, yes, it would be X and Y, but now it's M and C, where M is miles driven and C is the cost for renting this truck. So that's kind of set up for us. And again, we are looking for slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. But right here, we now know that instead of a y, we're using a c, and instead of an x, we are using an m. Okay, now the reason I'm setting that up is because I got two blanks that I got to fill in, and that's all. So what information did they give us? Well, they said up here that you got $2.50 per mile driven, and that right there is a unit rate. And I know that the unit rate is the slope. Okay, so my coefficient of x, I just found it, m. Not this m, but this red m. That's $2.50 for every mile driven. Okay, so 250m, C equals 250m, but now we need the y-intercept. So what other information did it give us? It said it was, if you drive 2 miles, it's going to be $25. Okay, so M, that's miles, that's 2 miles costing $25. And you could kind of just label those if you'd like, but you don't have to. Now again, the reason why we need this is because we now need to find the y-intercept, which is y minus the m, the slope times the x. And yeah, we already have the slope. It was given to us. That was $2.50 per mile driven. So the m, now I'm going to replace with 250. And the x, right there, that I see in the ordered pair is 2. So I replace the x in this with 2. And the corresponding y value there is 25 bucks. Now when I solve for this, which I'm just going to put into the calculator, it will tell me how much this truck would cost renting it without driving any miles. And when I put this in the calculator, which you should as well, you should get $20. Okay, so again, this $20, this is just the rental, some kind of rental fee. Why am I doing that? Because it didn't ask about it. Just so we know what we're looking at, right? So I know that it's $2.50 per mile driven. That's in the equation, but now I can include my plus 20 right there, and that's my cost equation. But again, if you'd like to, some students like this, where they say, well, it's $20, but then in addition to that, you're going to pay $2.50 per mile. Doesn't matter. Again, it's the same exact equation. We found the B, we found the M. That's it. But again, there's a lot of interpretation that happens with these word problems because you can. So even though you may be spending a lot of time just reading the problem, expect it, okay? Because until you get used to this kind of stuff, where we read it maybe twice there, 2 or 3 times, you may have to read it 4 or 5 or 6, 7 times. So at the end of some kind of snowstorm, you saw there was a lot of snow on your front lawn. The temperature increased and the snow began to melt at a steady rate. There's our rate. After the storm, the snow started melting at a rate of 0.75 inches per hour, and it is known that 4 hours after the storm ended, the depth of snow was down to 9 inches. Write an equation for S in terms of T, representing the depth of snow on your lawn in inches, T hours after the snow stopped falling. So once again, just identifying X's and Y's. Remember, it's always Y in terms of X. So I now know that my Y is the S, and then my X is the T. S is the snow depth. T is the time in hours after, I guess, the snowstorm ended. But again, we're looking at some kind of equation, Y equals mx plus b, where m is the slope and b is the y-intercept. But now, instead of using y and x, we now know we're using, instead of y, it's an s, and instead of an x, it's some number of hours after. So all I need is the slope and y-intercept. And they did give us the slope. That's the rate, 0.75 inches per hour. That would be my rate. In fact, it's a unit rate. I was going to say rate of change, which it is, but it's a unit rate specifically, which we know is the slope. Now, the slope is not 0.75. Yeah, but it says 0.75. That's true, but it's melting the snow, which means it's going to be losing 0.75 inches. That means it's negative. So instead of m right here, again, I'm just filling in that blank, negative 0.75. So that's my slope, but again, do we have a y-intercept? No. They didn't tell us how much snow was in the beginning, but what they did tell us is that after 4 hours, there was 9 inches of snow. So for my ordered pair right there, which is always x and y, but now I know x is time, and then y is snow depth. It said that that was 4 hours, so that's my x. After 4 hours of melting, there was 9 inches of snow. Okay, so again, if you want to label those just so you know, feel free to do it. But it's 4 hours for 9 inches. Now that is not a y-intercept, but it will help me to find the y-intercept b by taking the y value and subtracting the slope multiplied by the x. And we do have the slope already. That's 0.75, but it's negative 0.75. So again, even though this minus is always here for the y-intercept formula, so it's okay to, in the calculator, put minus a negative. That's okay. Next up, in my ordered pair, I know that the x is 4. So I replace the x with 4. And then I see that the Y value is 9, so I replace the Y with 9. Okay, and this will tell me my new Y-intercept. So I go to my calculator, 9 minus, again, it's negative 0.75 times 4. I plug the whole thing in, and it says, oh, it's 12. By the way, this Y-intercept is not just 12, it was 12 inches to start with. Okay, but that's my Y-intercept, positive 12 inches. But again, if you wanted to rewrite that, the amount of snow on the ground, it starts at 12 inches, and then you take away 0.75 inches every hour. That's fine. It's the same exact equation, just written in a different order. Now, there's another way you could have found that Y-intercept. You could have said, well, look, it's going down 0.75 inches every hour. So you could have taken your 9 inches at 4 hours, added an hour, which would have added 0.75 inches, and done that until you got to 0 hours, which would have told you the starting height of the snow when the snow stopped falling. So if you do it that way, though, that takes the place of using the Y-Intercept formula. Again, I like it. I'm going to use it because it's something that we are familiar with. But again, logically, you can just narrow this down and say, I'm just going to use my rate and go backwards in time. That would be fine as well. You're in the business of manufacturing phones. You must pay a daily fixed cost to rent the building and equipment, and also pay a cost per phone produced for materials and labor. So 2 parts to your cost. You got the rent for the building and equipment, and then you got the cost for producing a phone. Now just think about this. If you produce 0 phones, of course there's still going to be a cost for renting the building and equipment, which is going to be the Y-intercept. So it says the labor and materials cost $100 for each phone manufactured, and the total cost of producing 8 phones in a day would be $1,300. Write an equation for C in terms of P, representing total cost in dollars of producing P phones in a given day. So again, just starting out here, just identifying Y's and X's. It says C in terms of P. That's always Y in terms of X. So in my ordered pair, when I find it, which is X and Y, the X is P for number of phones, and Y is C for the amount of cost for producing those phones. So once again, we're looking for slope-intercept form, which is Y equals mx plus b. But again, now we know the Y, instead of using a Y, we're going to use a C for cost. And instead of an X, we'll use P for phones. All right, so going back to the problem, and just keep in mind, you may have to read and reread these problems several times to actually understand what's going on, just because you're not used to it, but hopefully in time you will. But $100 for each phone, that's a unit rate right there. How do I know it's a unit rate? Because it's comparing dollars for every 1 phone right there, and we know that the unit rate is the slope. So that's a cost. The M, right there, my slope now, I know is $100 for each phone. But what I need then is my Y-intercept, which it did not give me. So that will be, again, taking the Y value, subtracting the slope, times the X value. But did they give us enough information for an X and Y value? They did. Right here, they say 8 phones would cost $1,300. So P, which is the X, that's 8 phones. That was going to cost $1,300. So in my Y-intercept formula, yes, we do have the slope. We know it's $100 for every phone. And now I know that the X, that would be 8 phones, is going to cost, the Y value there is $1,300. So this is just something I got to put into the calculator, and this will tell me how much cost I would have in manufacturing phones for producing no phones. Put this into the calculator, and boom, you get $500. Now again, this is the cost. That's just renting the building and equipment. But it is my Y-intercept. Again, I have to pay that $500 whether I use the equipment or produce any phones. So this is my cost formula. And again, if you wanted to rewrite that instead, the cost being $500 to start with, plus $100 for every phone. That's fine as well. Another interpretation here, since we're looking at cost, is the 100p, that whole part right there. This is the cost to produce the phones. And then the $500 we know is the rent of the building. So again, there's more interpretation that you can do if you'd like, but I kind of assume you guys don't care, so we'll call it good. So on this problem also, instead of using the Y-Intercept formula, if you're struggling with that, start with $1,300 and 8 phones. You know it's $100 per phone. So go back one phone, take one phone away, take $100 away, 7 phones for $1,200, 6 phones for $1,100, and then go back until you get 0 phones, and that will tell you how much the cost of the rent is. Of course, what we did still works, but if you're struggling with that, it may be beneficial just to use the information they gave us, take out $100 for every phone until you get to 0 phones, and that works too. You find some nickels and pennies in your change jar. How many coins do you have if you have 120 nickels and 90 pennies? But also, how many coins do you have if you have N nickels and P pennies? So on this one, we know we're comparing the 2 parts to this one. We got nickels, and we got pennies. And for this first part, of course, they told us even how much of each there are. So it says 120 nickels. So for nickels, I got 120. And for pennies, it was 90. Now, it did ask how many coins you have. So the coins, nickels and pennies are both coins. So we're just going to add those together, and that would be 210 coins, which is our first answer. Now, the second part here just wants some kind of expression, some kind of formula you can use for finding how many coins you have. And since we're only finding nickels and pennies right here, we're going to take the nickels and add the pennies. But they did say specifically use N for nickels, so I'll use N. And then use P for pennies, so P for pennies. Add them together. That would be how many total coins you have. Now, you have to keep in mind on this one, these are not slope-intercept form. This equation is not slope-intercept form because they did not give us a slope. They didn't give us a y-intercept. We're just comparing nickels and pennies for coins. You'll have to keep in mind, though, if they said, well, find I guess, how much money you have. Okay, so if I looked at a formula for this one, you still have nickels and you still have pennies, and you'd still add those together, in fact, but a nickel is 5 cents, so we'd have to put 0.05 for dollars, and then pennies is 1 cent. And so you may have to write equations like this. Be prepared, because it's likely they're going to have equations that need to be written like this on the mastery quiz. In fact, they would even say, well, how many nickels and pennies would you have if you had, I don't know, like, let's just say $60. That's a lot of nickels and pennies, but again, it's just an example. But again, the 0.05 N, this is how much money you have in nickels. And then the 0.01 P, that's how much money you have in pennies. So again, it does not come out in slope-intercept form. It comes out in what we call this standard form. Okay, again, it's just a more direct way to write these equations, but you're gonna have to expect something like this on the quiz. Your math teacher finds that there's roughly a linear relationship between the amount of time students spend on their homework and their weekly quiz scores. This relationship can be represented by the equation y equals 8x plus 57, where y represents the expected quiz score and x represents hours spent on homework that week. What is the meaning of the x value when y equals 98? I'm going to do probably more work than you'd want me to do. Well, probably all this is. But it says y equals 98. Okay, so it says up here as well, y represents the expected quiz score. So this means we would expect a quiz score of 98 for, we don't know how many, but it just says X, for X hours. Specifically, X represents hours spent on homework, hours, I guess I'll say doing homework. So for these types of problems, just interpreting, in this case, the Y value, we did some intercepts and some other slope stuff on the last assignment, but for this one, we know the 98 represents an expected quiz score. That takes some reading, some maybe rereading for you guys. But when you do this stuff on the assignment, you need to see that 98 represents an expected score. It may not word it like this, like I have it, but you should still be able to make that interpretation. It gave you all the information you need in the word problem. So just keep reading and rereading that. Now over here, even though you wouldn't need to do this on the assignment, can we figure out how many hours this will be? Yes, we can. All we got to do is solve this equation for X. So right here, first thing I would do is get rid of the 57, right? Just like we would with a regular equation. So that zeroes that out. And I can drop my 8X there. But 98 minus 57, let's see, it'd be 141. And now finally, to solve this one, I'll just divide both sides by the coefficient, which is 8. And that's X. Again, X, that's hours doing homework for an expected score of 98. That gives us 5.125. But again, that's hours doing homework. So we know the X, even though you won't need that on the assignment, but you should be able to find this stuff just because we can interpret the equation and Y values if it's necessary. Well, there's our two objectives again. I can write equations from word problems, but also I can interpret and solve for X and Y values and slope and Y-intercept from word problems.